In 1812, Napoleon marched 600,000 soldiers into Russia. Fewer than 30,000 came home. For 2 centuries, every textbook blamed the same thing. They say it was the Russian winter that destroyed Napoleon's army. But the teeth say otherwise. The Russian winter, the most famous military excuse in history. Every documentary tells the same story. Napoleon invaded in summer. The army marched east. The winter came, and the army froze. That is the version 600 million people learned in school. But in 2001, construction workers in Vilnius found something buried underground. A construction crew digging foundations for a new building hit bone. Not one skeleton, not 10, 3,000. 3,000 skeletons packed into a single trench, many still wearing the buttons of Napoleon's Grande Armée, imperial eagle buttons, regimental insignia, belt buckles stamped with unit numbers. These were Napoleon's soldiers, and scientists wanted to know what actually killed them. A team led by Didier Raoult at the University of Marseille received 35 teeth from the Vilnius grave. Dental pulp, the soft tissue inside the root of a tooth. It is one of the best preserved sources of ancient DNA in the human body. The team extracted DNA from the pulp of each tooth, and they ran PCR amplification, looking for something specific. Not just any DNA, bacterial DNA specifically. The genetic signature of Rickettsia prowazekii. Rickettsia prowazekii. The bacterium that causes epidemic typhus. Typhus spreads through body lice. Soldiers living in cramped conditions without clean clothing become walking incubators. The fever starts with headaches, then a rash, then delirium. Within 2 weeks, the mortality rate in untreated cases can reach 40%. And in Napoleon's army, the conditions were perfect for an epidemic. The excavation took months. Every skeleton catalogued, photographed, and sampled. And the teeth were sent to one of Europe's leading ancient pathogen laboratories, Marseille, the south of France, where Didier Raoult ran one of the world's most productive infectious disease research units. Back to the teeth, 7 of the 35 samples tested positive for Rickettsia prowazekii. 20% of the sample carried typhus at the time of death. But that wasn't all. 3 additional teeth tested positive for Bartonella quintana. Bartonella quintana, another louse-borne pathogen, the bacterium that causes trench fever. 2 different diseases, both spread by lice, both found in the same mass grave. The soldiers were infested, and the pathogens were already spreading before the army ever reached Moscow. Here is what the numbers actually show. Napoleon crossed the Niemen River on June 24, 1812, with approximately 685,000 men. By mid-August, before any major battle, the army had already lost over 150,000 men to disease, desertion, and exhaustion. 150,000 gone in the first 2 months, and the army had barely fought anyone. Regimental rolls show companies that started with 150 men reduced to 40 before the first shot was fired. They weren't losing battles. They were losing soldiers to something they couldn't see. 150,000 gone in summer. No Russian winter. No major battle. Just disease and the march itself. The famous Minard chart, often called the greatest statistical graphic ever made, shows this visually. The band representing the army gets thinner and thinner before the soldiers ever see the Kremlin. Napoleon reached Moscow on September 14th with roughly 100,000 effective troops. He had started with nearly 7 times that number. Disease had already killed 4 times more soldiers than combat, and the retreat hadn't even begun. The army was dying from the inside out, and the retreat made everything worse. Commanders tried to separate the sick from the healthy, But by October, the distinction had become meaningless. But here's the twist. The teeth don't tell the whole story. Some historians pushed back on Raoult's findings. Their argument was simple: 20% positive doesn't mean typhus killed everyone in that grave. It means 20% of a small sample tested positive. The rest could have died of starvation, dysentery, hypothermia, or the catastrophic crossing of the Berezina River in late November. The Berezina alone killed an estimated 20 to 30,000 soldiers in 2 days. And the Vilnius grave itself represents soldiers who made it all the way back from Moscow. These weren't soldiers who died early. These were the ones who almost made it home. They survived the advance, the burning of Moscow, and the retreat through Russian winter. Then they died in Vilnius. And the question is whether the diseases they carried finally caught up with them, or whether the cold finished what the pathogens started. The answer, according to more recent analysis, is almost certainly both, but the ratio matters enormously. And the historical medical records from the campaign support the DNA findings. Napoleon's own chief surgeon, Dominique Jean-Larrey, documented the typhus epidemic in his memoirs. He described fever spreading through the ranks faster than the army could march. He recorded that entire regiments were reduced to half strength before they ever engaged the enemy. Half their soldiers gone before a single Russian bullet was fired. Hospital records from towns along the march route tell the same story. Smolensk, Vitebsk, Minsk, every town where the army stopped reported mass outbreaks of typhus within days. Every town along the march route became a temporary hospital, and every temporary hospital became a death trap. Vilnius, Kaunas, Minsk, Smolensk, each one a disease incubator. No one understood germ theory yet. The surgeons themselves were spreading disease from patient to patient. Local populations caught the disease from the soldiers passing through. Typhus followed the army like a shadow. And here is what makes the Vilnius finding even more significant. Raoult's team didn't just test for one pathogen. They tested for multiple diseases simultaneously. And the Bartonella Quintana results added a second layer. Trench fever, not as deadly as typhus, but debilitating enough to take a soldier out of action for weeks. 3 soldiers in the same grave carrying trench fever alongside, or instead of, typhus. The grave wasn't just a cemetery. It was a biological archive of the campaign's real killer. The excavation eventually revealed that the Vilnius soldiers died across a period of several weeks during the retreat. They arrived in waves, sick, starving, and freezing, and Vilnius had no capacity to treat them. The military hospitals in Vilnius were overwhelmed within days. Bodies were stacked in churchyards and eventually buried in mass trenches. And the DNA evidence confirms what the historical sources describe. The lice-borne diseases that plagued the army from the start were still present in the bodies at the end. These weren't fresh infections. The soldiers carried these diseases across 1,500 kilometers. The disease traveled with them, from the Niemen to Moscow and all the way back. And the implications extend beyond this one campaign. The process for extracting DNA from dental pulp is delicate. The pulp must be drilled without contaminating the sample. Once extracted, the pulp is dissolved and the DNA purified through multiple rounds of amplification. And then the search begins, not for human DNA, but for the genetic fingerprints of pathogens. A 2006 follow-up study expanded the analysis. Different mass graves, different conflicts, same pathogens. Researchers tested remains from other Napoleonic-era mass graves across Lithuania and Russia. Typhus and trench fever appeared in every single one, not just Vilnius, not just one regiment. The entire Grande Armée was a moving epidemic. And this reframes the entire narrative of Napoleon's Russian campaign. The conventional story has three acts: invasion in summer, the burning of Moscow, retreat through winter. But the DNA evidence adds a fourth act that was always there: disease from day one. Typhus was killing soldiers before the first battle at Smolensk in August. It was killing them as they entered Moscow in September, and it was still killing them in December when the winter finally did arrive. The winter made everything worse, but it wasn't the cause. The soldiers who reached Vilnius had survived everything: the march, Moscow, the Berezina crossing, and then they died, not from bullets, not from cold alone, from the pathogens that had been multiplying in their bodies for months. 3,000 of them buried in a trench that wouldn't be discovered for nearly 200 years. Modern estimates suggest disease killed approximately 60% of all soldiers lost during the campaign. Combat killed roughly 60% to disease, 10% to combat. The textbooks had it backwards. And this pattern isn't unique to Napoleon. Throughout history, armies have lost more soldiers to disease than to enemy action. The American Civil War repeated the pattern. 2 soldiers died of disease for every 1 killed in battle. It wasn't until antibiotics, vaccines, and sanitation reform in the 20th century that combat finally overtook disease as the primary cause of military death. The Crimean War, the American Civil War, the Boer War. In every major conflict before the 20th century, disease was the dominant killer. What makes Napoleon's campaign different is that we now have the molecular evidence to prove exactly which diseases were responsible. Ancient pathogen genomics has turned military history from a guessing game into molecular evidence. We're not guessing anymore. The DNA from their teeth is the testimony they couldn't give, and the research continues. In 2022, a team used next-generation sequencing to reanalyze remains from Napoleonic burial sites, producing complete genome reconstructions of the rickettsia strains found in the soldiers. The strain that killed Napoleon's soldiers is closely related to strains that caused typhus epidemics in the 20th century. The same pathogen lineage passed through lice from soldier to soldier across 2 centuries. The bacteria that killed soldiers in 8 and 12 are still around today. Ancient pathogen research is now conducted in some of the same high-security laboratories used for modern epidemic response. The tools have advanced enormously since Raoult's original 2001 study. What took months with PCR in 2001 now takes days with next-generation sequencing. Typhus still exists. It is endemic in parts of Africa, Asia, and South America. Anywhere poverty, overcrowding, and poor sanitation coincide with body lice, the conditions for an outbreak exist. And that is what makes the Vilnius finding more than just a historical curiosity. It is a proof of concept. Ancient pathogen DNA can identify the real killer when historical records are incomplete, biased, or simply wrong. Napoleon's letters blamed the cold. Russian historians credited their strategy. French historians blamed Moscow's fires. But the teeth don't have a political agenda. The DNA just tells you what was in the blood at the moment of death. Nobody can spin the data that comes out of a 200-year-old tooth. And so the story of Napoleon's defeat gets quietly rewritten, not in a political manifesto, not in a revisionist textbook, in a genetics laboratory in Marseille, 3,000 kilometers from the battlefield. 600,000 soldiers marched into Russia. The teeth of the ones who didn't come back are still giving testimony, and what they say challenges 200 years of storytelling. What killed Napoleon's army wasn't one enemy. It was an invisible one, riding on their own bodies. If this story changed what you thought you knew, subscribe, We publish new evidence-based investigations every week. The sources and studies referenced in this video are linked in the description below. Next time someone tells you the Russian winter defeated Napoleon, ask them about the teeth, because the teeth already answered.